Hello and welcome back to another video in our 1001 MSc online tutorial series. My name is Brock Grant and today we're going to be running through some questions on the composition of compounds and chemical equations. So let's get right on into it. So a couple of prerequisites as per usual for these modules. Highly recommend that you watch the first video of Module 7 as that's a lead up to doing these questions. It will also really help you to go through Module 6 and Module 4, so just looking through the chemical bonding, molecular structure, and how we name things. So that will come in very useful for trying to answer these questions as they're all sort of intertied. Also, just a quick note as well, in the YouTube player settings, as long as you have the annotations turned on, you'll be able to actually fast forward through this video just by clicking on the links down here. So the questions we're going to be working through are in 3 different chapters. We're going to be looking at chapters 7, 8, and 17, going through a wide variety of questions that will be tested throughout your examinations here. So let's get right on into it. So let's look at question 2 on page 139. So again, please pause this video, have a go at them yourself, and then we'll run through it together. So the question says, determine the molar masses. So that's the key term there. Determine the molar masses of these compounds. So we're going to go through Cr2O3. Now, something here that's very important for you to take note of are these subscript numbers. That's where that's really going to come into play. Now, in order to do the molar mass, we need to use the periodic table. So remembering that a periodic table will be provided to you for all examinations. So here is our periodic table here. So the first thing we need to look for is Cr. So we look for Cr on the periodic table and we can see it over here. So we can see the molar mass for Cr is 51.996, and that's safe to just round up to 52. Now we look at our overall compound that we're trying to calculate the molar mass of, and we can see that there are 2 lots of chromium, or Cr. So we know that the molar mass, or the weight of one of these per gram, is 52. So because there are 2 lots of Cr, what we do is we actually multiply 52 by 2, because there's 2 lots of them. Now again, when we're trying to calculate the overall molar mass, is we just simply add all of them together. So we've got the molar mass of our Cr over here. We now need to look at oxygen. So we add them together and we look at the molar mass for oxygen, and we can see that the molar mass for oxygen is 15.9994. Now again, that is safe to round up to 16. So again, we know that the molar mass for oxygen is 16, and we can see that there are 3 lots of oxygens, so we multiply this by 3. Now we do 52 times 2, so that is 104. So then we do 16 times 3, so 16 times 3 is 48. So now we have 104 plus 48, and that equals to 152 grams per mole. Now, very important when you're answering these questions, especially in an exam situation, is you must always put your units. Okay, if you just wrote 152, there are a very, very good chance that you would lose marks on that question. Because again, the units is what helps you paint a story. We don't know whether you meant 152 liters, 152 bowling balls. we just don't know. So your units tells us what this number represents. And the unit for the molar mass is grams per mole. Now let's look at another one here. This one's a little bit more tricky. So we've got MgHCO3 and in brackets 2. So this is where it's very important to know the composition of a compound and know what that chemical formula is trying to tell us. So again, what we do is we go to our periodic table and we need to look at the molar masses for all of these individual elements. So the first one we're going to look for is Mg, magnesium. So we've got Mg over here, and we had carbon, and we had oxygen. And lastly, we also had hydrogen. So we're just going to make a note on what the molar mass of each of these elements are. So magnesium is 24.3. Hydrogen was 1. Carbon was 12. And oxygen was 16. Now, there's no need to write them up on here like I have, because you can just you can remove the periodic table from your exam paper, just as long as you write your name on it. I've just written them up here, so I'm not sort of flicking backwards and forwards. So now we have a look at our compound here, and we add them all together. So we can see manganese was 24.3. So we go 24.3 plus, now this is where it gets a little bit tricky. So we've got in brackets HCO3. So bracket, now hydrogen is 1 plus carbon, which is 12, plus oxygen, which is 16 times 3. And then everything inside of this bracket is going to be times 2. Now, the reason for that is because we have, and this is denoted by this little subscript here, 2 lots of everything inside here. It means we have 2 lots of hydrogens, 2 carbons, and 6 oxygens. So we multiply this part here by 2. And so our molar mass for MgHCO3 2 is going to be 146.3 grams per mole. Okay, so let's move on now to page 140, question 6. So the question states, calculate the number of grams in each of the following. So again, pause this video, have a crack at it yourself, and then we'll work through it together. Now, it's very, very important to make sure that you very carefully read the question. Again, as I said in my previous video, is ask yourself, what is the question asking me to do? What does it want me to calculate? What information is it giving me? So we can see here that we have 4.25 times 10 to the minus 4 moles of H2SO4. Okay, so the first thing that comes to mind here is we can see calculate the number of grams. Okay, so it wants grams, or in other words, it wants the mass. And we can see here that within this question, we are given moles. So straight away, instantly, what should be coming to mind is the equation. Moles is equal to mass over molar mass. That equation should spring to your mind instantly. So we can see here that the number of moles that we have are 4.25 times 10 to the minus 4. So is equal to the mass. So we don't know what the mass is because that's the point of this question. So I'm going to denote that as X because it's unknown. Over the molar mass. So the molar mass, we can always find out the molar mass because we can use the periodic table. So H2SO4. So we look at the molar mass for hydrogen. So hydrogen, we can see over here is 1. And because there's 2 of them, it's going to be 1 times 2 plus. Now we look for sulfur. And we can see sulfur over here at 32.066. So we're going to round that to 32.1. So we're going to have 32.1 plus, and there are 4 oxygens. So it's going to be 16 times 4. So what we're going to do is we're going to simplify this portion here. And then we add all of these together. So again, you will have a calculator when you're answering these. So by all means, you simply can just punch this into your calculator. But I do recommend simplifying the steps down because it's very easy to make a calculator error and that can give you the wrong answer. So we're going to have 98.1. Now we rearrange this equation to isolate X. So the answer is 0.0417 grams of H2SO4. Okay, let us move forward now to page 140, question 22. So the question states, calculate the percent composition by mass of the following compounds. So remembering that when we're looking at anything to do with percent composition or percentages, we need to calculate the percent of the mass of the individual component divided by the mass of the overall thing, because that's how we calculate percentages. So our first one here is we're going to be looking at zinc chloride. So again, we need to look at the molar masses for each of these. So we have a look for zinc, and we can see zinc over here at 65.39. And now we have a look at the molar mass for chloride or chlorine. And we can see chlorine over here for 35.45 grams per mole. And the total mass is going to be 65.39 plus 35.45 times 2. So the total mass will equal 136.6 grams. So that's how much our total substance weighs. Now to find the percent composition, we now need to take the percentages of this. So for zinc, which is 65.39, divided by the total mass, which is 136.6 times 100. And the answer is 47.98%. Now we do the exact same thing for chlorine. So we look at Cl. Now remembering that with chloride over here, there are 2 lots of it. So we take the total mass of all the chlorines. So with chlorine, it's going to have a total mass of 70.9. And we divide that by the total mass. Times 100 will equal to 52.02%. And these are our percent compositions for zinc chloride. Okay, let us now move forward to our next one. So we've got Mg(P2O7). So again, we look at our molar masses for each. So we've got Mg, which is 24.3. We've got phosphorus, which is 30.97. And oxygen, which we know is 16. So we look at the total mass and we add all of these together, and we will get a total mass of 198.3 grams. So now again, we calculate the percentages of each individual element in this compound. So we have a look at manganese first. So manganese's mass is 24.3 divided by the total mass, which is 198.3 times 100 will equal to 12.26%. Now with phosphorus, again, we look at the mass of phosphorus, which is 30.97. However, again, be very careful of this, because this is a student trap a lot of the time, there's this 2 down here, which we must again take into account. So it's going to be 30.97 times 2 divided by 198.3 times 100 is going to equal to 31.24%. Now the lucky last one, I'll do this up here, is we're going to have oxygen. So oxygen is going to be 16 times 7 divided by 198.3 times 100 is going to equal 56.48%. So that means that the overall compound consists of 56.48% oxygen, 12.26% magnesium, and 31.24% phosphorus. Now the very last one that we're going to have here is FeNO3. So again, it's the same deal. We look at all the individual masses of these elements. So we look at iron. So we have iron over here, we have nitrogen over here, and we have oxygen over here. So again, we simply write down these molar masses. So we've got 55.85, so we'll round up. 14.0067, so we've got 14, and oxygen, of course, is 16. So now we calculate the total mass of this compound. So we go, we'll do that up here. So we've got mass 14 plus, because we've got O3, so I'm going to put that in brackets, 16 times 3. Because we have our bracket over here, and this 3 multiplies everything inside this bracket, we put this times 3. So what this means is we've got 16 times 3, and then inside that bracket is whatever this is plus 14, and then everything inside these outermost brackets here, and everything inside these outer brackets here is multiplied by 3. So that means that the mass total for FeNO3, as we can see down here, is going to be 241.9 grams. Now again, we calculate our percentages of this. So we go, the percentage for iron is going to be 55.85 grams divided by 241.9 grams, 23.09%. Now we look at nitrogen, because remember, we're calculating the elements. We're not calculating the mass of a compound within a compound. So we're not looking at NO3. We're just looking at the overall individual elements. So what we do is nitrogen. Now this is where it can be a little bit tricky, because we're going to take 14 times 3. And the reason for that is there is one nitrogen in here that is multiplied by 3. So it's going to be 14 times 3 divided by 241.9 grams times 100. And that will give us 12.37%. Now, oxygen, again, is the same deal. So oxygen is 16 times. Now, there are 3 oxygens in here, and that's multiplied by 3. So that means we have 9 oxygens total divided by 241.9 times 100 will equal to 59.53%. And that is the individual percent composition of these elements. Okay, so let us now go through page 140, question 26. Now I want you to, again, please pause this video, and I want you to try and attempt this question yourself, as this is essentially, it's a simple question, but that can trick you into looking more difficult than what it is. Okay, so the question states that a 35.75 gram sample of an alcohol was analyzed, and it contains 18.64% grams of carbon, 4.7 grams hydrogen, and the rest is oxygen. So calculate the percent composition of the compound. Okay, so a couple of things are jumping out at me here. The first one is a 35.75 gram sample. So that means that essentially the total mass is going to be 35.75 grams. Now, because this alcohol consists of carbon, hydrogen, and oxygen, we know, but they're being a bit sneaky here because they're not giving us oxygen. But that's okay, we don't need it. Because we know that the total mass is 35.75 grams, and we know 2 of the 3 masses of our elements, we can just simply deduct them from the total mass. So we know that we have 18.64 grams, and that's for carbon. And we also know we have 4.7 grams of hydrogen. So we subtract all of these, so we subtract these 2 numbers from 35.75, and we're going to get 12.41 grams of oxygen. Now that we have the individual masses of our elements, we can now get the percent composition of this compound by comparing the percentages of each of these individually to the mass total. So we will do carbon first. So carbon is, now again, the total mass is 18.64. So we go 18.64 grams divided by the total mass, which is 35.75, times 100, and that will equal to 52.14%. Now let's do hydrogen. So hydrogen was 4.7 grams. So we're going to have 4.7 grams divided by the total mass, which is 35.75 grams, times 100, and that's going to equal 12.37%. And the last one, oxygen. So oxygen is 12.41 grams. So 12.41 grams divided by 35.75 grams times 100, and that's going to equal to 59.53%. Okay, let us now move on to page 165, question 8. So the question says, balance the following equations. So what we do is, we now need to look and make sure that everything on the left equals everything on the right. So I'm going to draw out my table, so left. Now I do recommend that you draw this in pencil, as sometimes it can be a little bit messy if you're doing it in pen. So sodium, we have 1 on the left. Hydrogen, we have 2. And oxygen, we have 1. Now on the right-hand side, we have 1 sodium. We have 1, 2, 3 hydrogens. And oxygens, we have 1. Okay, so this is a little bit tricky here. So what do we do? How can we balance these out if it's an odd number? So what I'm going to do is, because I can see we've got an odd number with an even number, the easiest way to help get rid of that odd number is to just multiply everything in the equation by 2. Now, the reason for that is odd times odd equals even, and even times even is even. So by doing this, it makes sure that all of our numbers are even, and it's a lot easier to work with. So I'm going to put a 2 here, a 2 here, 2, 2. And what that has done is that has now doubled everything in our table. So again, we're going to have a look. We're going to do a quick check again. So on the left-hand side, we have 2 sodiums. 2 times 2 is 4. So we're going to have 4 hydrogens. And 2 times 1 is 2 oxygens. Now again, on the right-hand side, we're going to have 2 sodiums. We're going to have 2 times 1 is 2, and 2 times 2 is 4. So we're going to have 6 hydrogens. And then oxygen, we're going to have 2. Now we can see that on the right-hand side, we have too many hydrogens. So now we look back at our equation and we go, okay, what is the best way that we can remove 2 hydrogens? And the answer is we remove this coefficient. Because by doing so, if we recount our hydrogens, 2 times 1 is 2, and we have 2 hydrogens here, which is 4. So now we can see we have the same number of elements on both sides, therefore this is our balanced equation. So now if we look at our next formula, we can see we've got a lot of things going on here. So again, we draw our table out. So we go left and right. So now we count out the number of elements of each element in our equation. So we look now on the left-hand side. So we have 2 lots of beryllium, Bi. Sulfur, we have 3. Hydrogen, we have 1. And chloride, we have 1. Now on the right-hand side, we have 1 lot of beryllium. We have 1 sulfur. we have 2 hydrogens, and we have 3 chlorines. Okay, so we've got a few things a little bit everywhere. Now, the first, did I just write Bi there? So the first thing that we do is we can see here that our beryllium is 1 off and our sulfur is 2 off. So we're going to start with those first. So I'm going to put a 2 here, and I'm going to put a 3 here. Now, again, when you're balancing these equations, you can only add coefficients. You cannot add these little subscripts, okay? They cannot be altered. Now, because we changed some of the coefficients, I'm going to recount the right side again. So, how many of beryllium, Bi? We have 2. Now, chloride, we have 6. Now, 3 lots of sulfur, so we're going to have 3. And H2, so 2 times 3 is 6, so we're going to have 6 hydrogens. Now, we can see over here that we have 6 hydrogens to 1 hydrogen on the left, 6 chlorides on the right side, and 1 chloride on the left. So that's pretty easy to rectify because we're just going to put a 6 here. So now we check our answer. So we have 2 berylliums, 3 sulfurs, 3 sulfurs, 6 hydrogens, 6 chloride, 6 chloride. And that is our balanced equation. Now we're going to move on to question 2 of page 434. So the question says, determine the oxidation number of each element in this compound. So again, when it comes to the oxidation number, it refers to the electrons. How many electrons have been lost or gained within this compound? So if we have a look at SF6, okay, we determine the charge of our sulfur and our fluorides to see what's going on. So we know with very good certainty that fluoride is going to have a charge of -1 because remember, when we've got 2 anions, which is 2 elements on the right side of the periodic table, the one that is the most electronegative will have the negative charge. So that was in our redox rules that we discussed in the previous video. So we know that fluoride is going to have a charge of -1, and because fluoride has a charge of -1 and there are 6 fluorides, it will have a charge of -6. Now, we can see too that there is no charge within this compound. It is neutral. So that tells us that the charge of sulfur must be +6. Now let us have a look at CH3OH, or otherwise known as methanol. So OH, hydroxide group, it would be very useful for you to memorize that it has a charge of -1. Now, the reason why it has a charge of -1 is that we know that oxygen has a charge of -2 and hydrogen has a charge of +1. So -2 + 1 is -1 overall. So we know that hydroxide here is -1. And again, when we've got a compound consisting of a nonmetal with a nonmetal, we know that the one that is the most electronegative will have the negative charge. So because of that, this tells me that the hydroxide group will be -1, and this methyl group, or CH3, will have a charge of +1.